Hi, everybody. It's Professor Mitchell. We are continuing with Chapter 9. This section is called Developing Hypothesis and Understanding Possible Conclusions. Now, it's not a very specific description of what this section is about. The objective, we'll get into it a little bit better. And that objective is to compute the value of the test statistic, the t-value, and degrees of freedom for a hypothesis test with one population mean with an unknown population standard deviation. So in the previous sections, we've talked about the case where the population standard deviation is known. And in that case, we use the z-score for the test statistic. So now we're dealing with the more realistic case where the population standard deviation is unknown. When studying an entire population, it is rare that the standard deviation sigma is known. And that makes sense, right? Because you don't know the population mean. So why would you know the population standard deviation normally? When the population standard deviation sigma is known, the z-score is used as the test statistic because its calculations use the value of sigma. However, when sigma is not known, then we perform a hypothesis test called the one-mean t-test. The hypothesis testing procedure looks the same, but the value of the test statistic varies just a little bit. So to perform a hypothesis test for one population mean mu with sigma unknown, we need to work through these steps. Number one, just like before, we'll choose the null hypothesis and the alternative hypothesis. Also, same as before, we'll decide on the significance level, alpha. In a statistics class, that value is usually given. Then we will compute the test statistic, which is the t-score. So that part is different. But then we'll find the critical values to reject or accept the null hypothesis. How that will work will be a little bit different. When we're working with the t-score, we will use table A3 instead of table A2. So if you think back to the last chapter on confidence intervals, we used table A3 when we were working with t-score. And then finally, we will interpret the results of the hypothesis test. After the null and alternative hypotheses are chosen and the significance level is decided upon, we must use the parameters of the situation to compute the value of the test statistic, or t-value. If a variable x is normally distributed with mean mu for samples of size n, then the t-value is given by this formula. And I notice a typo that they've had a couple of other times. Sorry, I didn't notice this before. That should be an x bar. That does not look like a bar. Let me try to fix that. Here we go. If I do it like, there we go. That's better. Okay. X bar minus mu divided by S over the square root of n. So the only difference between this and using the z value for the test statistic is that where you see an S there, we're now going to, we used to put sigma there, okay, when we knew sigma. S is the sample standard deviation, and that test statistic has distribution with n minus 1 degrees of freedom. And again, we worked with that a little bit in the last chapter. Okay. Using the sample values from a hypothesis test, the formula to compute the test statistic looks like this. So it's pretty much the same formula we were just looking at. Mu sub 0 will be the value of the population mean from the null hypothesis. So what I sometimes call the hypothesized mean. So in a world where the null hypothesis is true, the sample that you collect will have a t-score that's given by this formula. And that will give us a sense of how unusual it would be to have a sample that extreme. And based on that, we will decide whether to reject or fail to reject our null hypothesis. And remember the notation in this formula: X bar is the sample mean, S is the sample standard deviation, N is the sample size, and again, mu sub 0 is the number the population mean is being compared to from the null hypothesis. All right, so here's a little example. A busy student is trying to determine whether attending review sessions actually helps exam grades. He asks a group of 9 of his fellow students who attended review sessions last semester about their exam grades when they did and did not attend review sessions. The population mean for a given exam is 24. Hopefully that's not out of 100. And the sample mean is 25 with a standard deviation of 4. So the question is, should this student use a z-test or a t-test for this study, and why? So when you're trying to answer this question, the only thing you need to look at is the population standard deviation known or not? So I see one mention of standard deviation. This is the standard deviation of the sample. The sample mean is 25 with a standard deviation of 4. So that is definitely a sample standard deviation. We don't know the population standard deviation, so this student should use a t-test. Okay. And next, according to a survey, the average American person streamed 3.5 hours of internet programming per day during 2015. To test if the amount of internet programming watched per day differed last year from 2015, a researcher decides to do a hypothesis test at a 10% significance level. He surveys 25 people randomly and asks them about the amount of television they watched per day on average last year. From the data, the sample mean time X bar is 3.9 hours, and the sample standard deviation S is 1.3 hours. So if we're setting up our hypothesis test, the first thing we would do is write the null and alternative hypotheses. Usually I recommend writing the alternative first. And to determine whether this is a left tail, right tail, or two-tailed test, you look at what the claim is sort of against the status quo. And that's right here. To test if the amount of internet programming watched per day differed last year. So they're not claiming it went down, they're not claiming it went up, they're just wondering if it's different. So that would be a two-tailed test. The claim is that maybe mu does not equal 3.5 anymore. The null would be mu equals 3.5. Remember, the null hypothesis always contains equality. And in the case of a two-tailed test, the null hypothesis would always be equals. Okay. Alpha is 0.10. They said 10% significance level. And right now they're just asking, what is the test statistic of this one mean hypothesis test with sigma unknown? Notice again, they only gave me the sample standard deviation. Okay, so the hypotheses were chosen, the significance level was decided on, so the next step is to compute the test statistic. And that's going to be a t-value because the population standard deviation is unknown. In this scenario, the sample mean amount of time, X bar, is 3.9. The research uses a sample size of 25 people. So n equals 1. The population standard deviation is unknown, but from the sample data, the sample standard deviation can be calculated, and that came out to 1.3. So S is 1.3. And lastly, the study is comparing the population mean internet programming streaming time, extra time in there, to 3.5 hours. So this value found in the null and alternative hypotheses is mu sub 0. So now we're ready to calculate our test statistic using this formula, filling in 3.9 for X bar, 3.5 for mu sub 0, 1.3 for S, and 25 for N. Just double checking to make sure, yes, that this is correct. So Try to plug this into your calculator. Make sure that you get the same value that they did, which I just checked is correct. Okay. Comes out to 0.4 divided by 0.26, which is about 1.54. So the test statistic for this one mean hypothesis test is T0 equals 1.54. So in the next section, we will talk about finding critical values. In a later section, we'll talk about how to find p-values. Okay, right now we're just practicing calculating the test statistic. So that's the end of this video.